Hello, welcome to our first lesson in exponent laws. In today's lesson, we are going to explore two different laws. So let's start off with our first one here. I'm going to write down a bunch of powers that are multiplied together, and with these, let's see if we can figure out a pattern or a law. There's a very good chance that you'll be able to figure out the law before I even give you the law. So let's start at the very beginning. We're going to start with 3 squared multiplied by 3 to the power of 5. Then we're going to look at 4 squared multiplied by 4 cubed. Next we're looking at 5 squared, and that's going to be multiplied by 5 to the power of 4. Then we're going to be looking at 2 squared, and that's going to be multiplied by 3 squared. Next we're going to look at 5 squared, and that's going to be multiplied by 4 cubed. And then lastly, we're going to look at 2 cubed multiplied by 2 cubed. So right here, we already noticed one thing. I am looking at products of powers. And we're going to see if we can find a pattern here. So first we're going to do it in expanded form. And then we're going to see if we can simplify my expanded form. Okay? So let's take a look at my very first one here. We're going to have 3 squared is 3 times 3. And we're going to multiply it by 3 to the 5. So that's 3 5s. So 3 repeated 5 times. So I look at this. Altogether I have 1, 2, 3, 4, 5, 6, 7. I have 7 3's being multiplied together. So that's going to give me 3 to the power of 7 if I simplify it. Let's look at my next one. Here I have 4 squared, so that's 4 multiplied by 4. And this is going to be multiplied by, and we have 4 cubed, so that's 3 4's multiplied together. Now looking at this here, I have 1, 2, 3, 4, 5 4's being multiplied together. So this is the same thing as 4 to the power of 5. Okay, so let's look at what we started off with and what we're finishing with the expanding in between. Let's try my next one. Here I'm going to have 5 squared. So that's 5 times 5. Multiplied by 5 to the power of 4. So that's 5 times 5 times 5 times 5. We have 5 multiplied 4 times. Base is 5, exponent 4. So that's how many times they're multiplied together. Altogether here, we're going to now have 5 multiplied together 6 times. So that's base 5, exponent 6. Let's take a look at my next one. Here we have 2 multiplied twice. Okay? Then we have 3 multiplied by itself twice. I look at this, we cannot simplify this really that much. This is the same as 2 squared multiplied by 3 squared. Some of you might say, hey, this is also equal to 6 squared, because order of multiplication doesn't matter. 2 times 3 is equal to 6, and then 2 times 3 is equal to 6 again. You could say that there too, but that's not really what we're looking for. Let's take a look at my next one. This one here is going to be 5 squared. Oops, 5 squared, so that's 5 times 5. And that's multiplied by 4 3 times. 4 being multiplied 3 times. Okay, so altogether here, we can't simplify this at all. This is going to be the same as 5 squared multiplied by 4 to the 3. It doesn't simplify anymore. Here's my next one. And I'm going to probably give one more here. So this one here, we're going to have 2 multiplied by 2 multiplied by 2. And that's all multiplied by 2 multiplied by 2 multiplied by 2. Okay, we have 3 2's, yep, and 3 2's. Good. Now look at that all together. I'm going to have 2 to the power of 6. Let's give you one more here. I'm going to say 5 to the power of 3 multiplied by 2 to the power of 3. So here we have, or 2 to the power of 4, we'll say, sorry. So here we're going to have 5 times 5 multiplied by 5, all multiplied by 2, by 2, by 2, by 2. So this ends up giving me, well, we can't simplify any of these here. This is the same thing as 5 to the 3 multiplied by 2 to the 4. Okay? There is a way of simplifying a bit. I could say this is 10 to the 3 and 2 to the 1. And this one here, because if we look, 5 times 2 is 10, 10, 10, and then we still have a 2. And same with this one here, I could say 20, 20, and then we have a 4. So this we can say is equal to 20 squared, and then we multiply it by 4. But now, looking at that there, that doesn't really simplify anything. So really, if we look at this here, we have a pattern here. Let's look at this here and look at these. So this is my pattern. Every time we're multiplying powers with the same base, we can simplify by adding the exponents. And that is called the product rule. So now I'm going to look at something called the product rule. Okay? So the product rule is, if we multiply powers with the same base, we can simplify by adding the exponents. Okay, so what that means is if I have two bases that are same, so x to the m multiplied by x to the n, right? We have two bases the same. Now we're multiplying them together. That means we could just add our powers together. So my base is going to stay the same, and we just add our powers, which is going to give me m plus n. All right, so let's look at a few examples here. Here's going to be my first example, looking at that rule. My first example here is we're going to have 5 to the power of 6 multiplied by 5 to the power of 4. Now if I look at that there, we have the same basis, so we could just add our exponents. This is equal to 5 to the power of 10. Let's look at my next one. We're going to have 7 to the power of 3 multiplied by 7 to the power of 5. Once again, we have the exact same basis, so then we could just add my exponents. That's going to give me 7 to the 3 plus 5 is 8. Now let's look at a third example. This one's going to be a bit trickier. Here I have 4 to the power of 6 multiplied by 4 to the power of negative 5. Well, we still have the same basis, so we have a 4. Now we have to add my exponents. I have positive 6 and then negative 5. So we're going 6 plus negative 5, that's going to give me 4 to the 1, or just 4. Now let's look at my last one. For this one, let's try 3 to the 5 multiplied by 3. Now look at this here. This has an imaginary 1 there. So it's really 3 to the power of 1. It's just imaginary. So this is going to be 5 plus 1 is 6. So it's 3 to the power of 6. So now we're going to look at my second rule. And it's going to be based on division. So I'm going to do the same thing that we did for the last rule. So I'm going to start off here with a few numbers being divided, or a few powers being divided. So I'm going to have 3 to the power of 4 divided by 3 squared. Okay? The next one, I'm going to have 8 to the power of 7 divided by 8 squared. My next one, I'm going to have 5 to the power of 6, and we're going to divide that by 5 to the power of 4. Then my last one is going to be 5 to the power of 7, or second last one, sorry, divided by 4 to the power of 3. And then here's going to be my very last one. We're going to have 4 to the power of 3 divided by 3 to the power of 3. Okay, so once again, we're going to expand. And then we're going to write out my simplified version over here. Okay? So this first one, let's expand. So that's 3 multiplied by 3 multiplied by 3 multiplied by 3. And then we want to divide all of this by 3 multiplied by 3. Okay? So all of this here is being divided by this. Okay? So now if I look at that, well, 3 divided by 3 is 1. 3 divided by 3 is 1. So I am left with 3 squared. Let's take a look at my next one. We have 8 multiplied by 8 multiplied by 8 multiplied by 8. We have 1, 2, 3, 4, 5, 6, 7. So we have 8 multiplied together 7 times. Now we're going to divide this all by 8 multiplied by 8, 8 squared. Now if I look at this, that 8 divided by 8 is 1. Okay? 8 divided by 8 is 1. So I'm left with 1, 2, 3, 4, 5. So that's the same thing as 8 to the power of 5. You might be getting the pattern already. Let's try this next one here. So I want 5 to the power of 6. So that's 5 multiplied by 5 multiplied by 5 multiplied by 5 multiplied by 5. All divided by 5 to the power of 4. So we have 1, 5, 2, 3, 4. Okay? Now, once again, let's do our divisions. 5 divided by 5 is, well, 1. 5 divided by 5 is 1. 5 divided by 5 is 1. 5 divided by 5 is 1. So I'm left with 5 squared. Okay? Let's take a look at my next one. We have 5 to the power of 7, so that's 7 5s. 1, all divided by 4 3s. Okay? Now I look at this, there's nothing that could divide anything. So this is left at 5 to the power of 7 divided by 4 to the power of 3. That's it. It can't be simplified. I wonder why this can be simplified, but these here could. What's the difference in my initial question? Let's take a look at my next one. So my next one here is 4 to the power of 3, so that's 1, 2, 3, 3 4s. And then we're dividing by 3 3s. Well, this, I look at it, can't be simplified as well. This is just going to be 4 to the 3 divided by 3 to the 3. So those cannot be simplified as well. So now I look at this here. Let's look, how do I get from 3 to the power of 4 divided by 3 to the power of 2 is simplified to 3 squared. 8 to the power of 7 divided by 8 to the power of 2 is simplified to 8 to the power of 5. 5 to the power of 6 divided by 5 to the power of 4 is 5 to the power of 2. 5 to the power of 7 divided by 4 to the power of 3 cannot be simplified. 4 to the power of 3 divided by 3 to the power of 3 cannot be simplified. So what is happening here? Well, this is what's happening. This is called our quotient rule. Okay? So, if we are dividing powers with the same base, if we are dividing powers with the same base, okay, we subtract the exponents. So in other words, so we have a base here to the power of m, and we're going to divide that by x to the power of n. We have the same base. We are just going to subtract my exponents. That's the same as x to the m minus n, and we do nothing to our base. So let's look at a few examples. So let's try 3 to the power of 5. And we're going to divide that by 3 to the power of 3. Well, that's going to be the same thing as 3 squared. 5 minus 3 is 2. Now, what if I wrote it like this? There's example 1, example 2. 5 to the power of 6 all over 5 to the power of 4. I look at that there. This is 6 minus 4. That's going to give me 2. So that's the same thing as 5 to the power of 2. We just subtract them. Here's one more example. If I have 3 to the power of 7, and we want to divide it by 3 to the power of 9. Well, we have to go 7 minus 9. 7 minus 9 gives me negative 2. So that's going to give me 3 to the negative 2. Okay? So we can't have negative exponents. All right, now we're going to look at one more style here. So we looked at multiplication, we looked at division. Now we're going to look at adding and subtracting. So let's take a look at this example here. What if I have 4 squared, we're going to plus 4 cubed. We're going to see if this can be simplified. So if I expand this, this is going to be 4 multiplied by 4 plus 4 multiplied by 4 multiplied by 4. Now I look at this, this is just going to give me, I look at this right here, 4 multiplied by 4 multiplied by 4, that's 16, and this is going to be 64, 64, so 16 plus 64 is 80. There is no simplification of this here. This is the only way we could simplify it into power form, is that. Okay, let's try one more. Let's try 3 to the power of 4 plus 5 to the power of 3. Okay, so these ones here were the same bases. Now we're looking at ones with different bases. That's going to be 3 multiplied by 3 multiplied by 3 multiplied by 3 plus 5 multiplied by 5 multiplied by 5. Okay, bed mass again, do all my multiplication first. So that's going to be 9 multiplied by 9, which is 81. This is going to be 25 multiplied by 5, which is 125. And we want to add these together. So now we have to go 81 plus 125. That's going to give me 206. Now I look at this again. There's no way of simplifying this. This can't be simplified into powers in any other way. Let's try one with subtraction. So let's try 4 to the power of 3 minus 4 squared. Maybe this will give us a little hint. So once again, we're going to expand this. 4 multiplied by 4 multiplied by 4 minus 4 multiplied by 4. Okay, so we already did this on top before. We know it's 64. Subtract, this is 16. We subtract these, well, that's going to give me 48. I look at that, there is no simplification to be had. So basically what this tells me is we have a rule for when we multiply powers with the same base. We have a rule when we divide powers with the same base. But if we add or subtract powers with the same base or even different bases, there is no rule. So in today's lesson we learned when we multiply powers with the same base, we add the exponents. When we divide powers with the same base, we're going to subtract the exponents. And if we add or subtract powers with the same base or even different bases, there is no law to follow or rule to follow.